This is the review of the homework from section 2.6. Okay, and the first problem we come to is problem on page 107, problem 2A. And the problem states, use long division to divide f of x equals x to the fourth plus 5x to the third divided by x plus 2. And you're not using synthetic division. You're using long division. So that's too bad, because this is a much more complicated and time-consuming method of doing it. The first thing you want to do is take the first term and divide it by that first term. X to the fourth divided by x. We're going to be learning how to do this today, which is really sort of ridiculous, right? Because that should be before this, but I just work here. So x times x times x times x over x. This is what we're looking for. That cancels out. You get x to the third. It goes over here. Then you want to multiply x to the third times x plus 2. You go back over here on the side. You take x plus 2 times x to the third. This is a 3. X to the third times x is x to the fourth plus 2x to the third. So x to the fourth plus 2x to the third. And we're doing division. So when you do division, you change the signs. This cancels out. Here you get 3x to the third plus 6x squared. Now, some people, when they do this problem, bring everything down. They bring down the negative x, they bring down the negative 2. You could do that if you want, but I personally don't do it that way. Okay, now the next question is, what is 3x to the third divided by x? 3x to the third divided by x. So as we're going to learn in a little while, when you divide exponents, when you're dividing monomials, you subtract the exponent. 3 minus 1 is equal to 2. So that's what goes up here. Plus 3x to the second. And then 3x to the second times x plus 2. X plus 2 times 3x to the second becomes 3x to the third plus 6x squared. 3x to the third, that's good news because that's what we wanted. Oh, look what happens here. Whoa. See what happens? Everything sort of drops out. We have 0. Doesn't make a difference though. We don't care what happens here because we bring this down. This is why people sometimes bring it down. Let's bring both of them down. What the heck, right? Bring them down. And now we want to divide negative x by x. And that's going to be negative 1. And that's what goes up here. Oh, you don't put it over the x, you put it over there. And then you multiply negative 1 times x is negative x. Negative 1 times positive 2 is negative 2. No remainder. There it is. So the answer is x to the third plus 3x squared minus 1. That's how you divide polynomials. 108, problem 5. And use synthetic division. Yes, right? 5x to the third minus 6x squared plus 8 divided by x minus 4. All right, so we're using synthetic division, thank goodness, right? Because this is how you use synthetic division. Step one, remember? Step one, and then this, step two. Oh, I see. Okay, well, we got a slight problem, right? Sorry about this too. Well, I didn't realize it until I got to this point, so who cares? 5x, f of x equals really 5x to the third minus 6x squared. Now, what shall I do now? What's left out between here and here?
X.
An x, we got to put an x. But, it's not really there, so you put 0x divided by x minus 4. That has to be done. You got to put that 0, otherwise you're going to get all messed up. Okay, now we're ready to use synthetic division. And we have 5, -6, 0, and 8. Then you take the opposite of -4, and that goes over there. And here's the process of synthetic division. Bring down the 5. 4 times 5 is 20. -6, +20 is 14. 4 times 14 is 56. Oh, this is just terrific. 56. 4 times 56 is 224. I mean, sometimes it doesn't work out exactly. So this becomes over here 232. So what this is, all of this becomes 5x squared, because you go down by 1. If this is to the third power, you start here with the second power. See, whenever we do a division, like the division we did up on top, this was an x to the fourth, but the first one was an x to the third. So that's what you have to take into account. And this becomes 5x squared plus 14x plus 56x plus 232 divided by the original divisor of x minus 4. There it is. Okay, what's wrong here? There's no x here. Of course, there's an x there already, so there can't be an x there as well. I don't know, is this right?
So when there's an x, there can be a remainder.
Yeah, there can always be a remainder. You can always,
Okay.
it can always work out. If they're telling us to divide a polynomial by, it's got to be a binomial. You can't divide by, it's got to be an exponent of 1, a coefficient of 1. It's got to be that in order to use synthetic division. But, who's to say it? There's a remainder, there's a remainder. This was a division problem using synthetic division. And this was the division problem, it's x to the fourth, so it's a little more complicated. But look at the difference. It's just so much cleaner and nicer. Okay, let's go on to the next one, since nobody's asking a question. Page 109. Problem B. Use the remainder theorem. This is question 6B, I suppose. This is, use the remainder theorem and synthetic division to find each functional value. So we want to find h of -2. And the function that we're given, actually, this is not a good way to write it. The way to write it is you always write the function first. H of x equals x to the third minus 5x squared minus 7x plus 4. And we want to find h of -2. And they want us to use two methods, the remainder theorem and synthetic division. Well, the remainder theorem, if you remember correctly, simply tells us that if we substitute this in here, we're going to wind up with either 0 if there's no remainder and it's actually a factor, or let's just say, -2 to the third minus 5 times -3 to the second minus 7 times -2 plus 4. This is the original function. This was what happens when we substitute the -2. I want to make sure I did everything the way I want it to come out. All right, now, -2 to the third is -8. And -5 times,
Shouldn't that be a -2?
Yeah, shouldn't be 2.
oh yeah, why did I put a 3? Maybe because I wanted to hear the human voice of one of my students. Did that ever occur to you that I did that purposely because nobody's saying a word? And I thought that somebody would correct me. You can believe that if you want, it's up to you. Plus 4. Okay, now let's see if we can figure this all out. So we have -8 minus 20 plus 14 plus 4. -28 positive 18 equals -10. In other words, h of -2 is equal to -10. All right, now they also want us to use synthetic division. And we know that when we use synthetic division here, that we are going to wind up with, we hope, and this will verify, a -10 as a remainder. This is the remainder theorem, which means that we're substituting the -2. And if there's a number, that means that in other words, it means that x plus 2 is not a factor, is not a factor. If you remember from last week, I said that if the factor theorem is that if you substitute this and it comes out to 0, then x plus 2 is a factor. But it comes out to a remainder, which means that x plus 2 is not a factor. Now we want to use synthetic division. Let's see if we can squeeze it in. Okay, so 1, -5, -7, positive 4. And we're using -2. And we put the 1 over there. This is where we are right now. Again, we took the 1 from here. There it is. The -5 from here. There it is. -7 and 4. And we put the -2 on the outside. We bring down the 1. -2 times 1 is -2. This is -7. -2 times -7 is 14 positive. This comes out to 7. This comes out to -14. And what do we get? -10. And there, that's the verification right there. This is, my God, look how beautiful this is. I just, okay, I've gone very overboard when it came to the synthetic division. But look how nice that worked. 1 times -2, and if you do the sign numbers correctly, there's the remainder. There's the remainder. It's like using the remainder theorem, but look how quickly and easily and neatly it came out compared to this. And I put the wrong number over there. All kinds of things can go wrong. But the verification that the problem is looking for is that using the remainder theorem, we get -10. And when we use synthetic division, we see that there is a remainder. And the remainder is the same number, -10. You are given a function, f of x equals x to the 4th minus 4x to the 3rd minus 15x squared plus 58x minus 40. You're given. Why would a person write a 20 when it says 40? Welcome to mathematics. And the question is, you're given this function, you are told that these are 2 of the factors. You are told that those are the 2 factors. That's pretty nice of the problem, right? Pretty nice, yeah. Let me see if I have that right. Do I have all the numbers right? Okay, now the question says verify the given factors of f of f, and then find the remaining factors. Now we could use the factor theorem. In other words, we could substitute the opposite of -5, which is 5, into what? No. Well, you know something? I don't like the factor theorem. I'm using synthetic division. I like synthetic division. I'm going to do this using synthetic division. I strongly recommend that you use synthetic division. And let's use the x minus 5. So we're using x minus 5. We take the opposite. And now we're ready to go. Now, if this is a very important thing. Focus on what I'm about to say. If this is a factor of this, then when I use synthetic division, the remainder will be 0. Now they're telling us that this is a factor, therefore, I know that's going to be 0. If it's not, either I've made a mistake or we were lied to. But let's see what happens. 5 times 1 is 5. 1, 5, -10, -50, 8, and 5 times 8 is 40. And what's the remainder? The remainder is 0, because these drop out, and this is the remainder. I like that better than the remainder theorem, or the factor theorem, because this not only tells us that, yes, it is a factor, x minus 5, but it suppresses the equation So that we're now working with the equation x to the third minus x to the second minus 10x plus 8 equals, well, I guess it could be 0, but let's just keep it as f of x. Okay, right? So now we're down here. Now we want to determine if x plus 4 is a factor. So we once again, well, something, this f of x looks crazy on the right side, doesn't it? You never see that. You see it over here. Okay, synthetic division. -1, -10, 8. You take the opposite of +4 is -4. Again, since they are telling us that x plus 4 is a factor, we will know that this will also be a 0. That's how synthetic division is used to determine a certain binomial is a factor.
Professor,
Yes.
for the first f of x, isn't it supposed to be x to the third plus x to the second? No, the result.
Oh, here.
Yeah.
Oh, thank you. 4, -3, +12, 2, -8, 0. Perfect, right? Yeah, excellent. Now, if I had made that -1, I would have said, uh-oh, what's going on here? So I thank you. Good. I'm going to keep that in the video. I want people to know that I'm not perfect. You want a perfect professor, you got to hire somebody else. But I've been making mistakes. I've been at BMCC now 42 years, 42 years of mistakes. So where are we now? We are at x to the second minus 3x plus 2. And if we want to, continue with this, we could factor this. Let's just factor it now. So, I love synthetic division. It's pretty known by now that I do, but let's just factor this. I like factoring also. X, 2, it has to be 2 and 1. And to get a negative in the middle, when you add the factors and a positive over there, you need negative and negative. And that's it. These are all the factors. This is a factor. You don't even need to put the negative because you're not really solving an equation, So it's really f of x. That's why they keep doing that, because you weren't being asked to solve an equation. So the answer to the question is x minus 5, which is what they gave us, plus x minus 1 times x minus 2. These are all the 4 factors of the original function. And this is called, and part C of the problem, incidentally, is to find the complete factorization. This is called the complete factorization. And now we move on to chapter 2.7. And how many problems do I give here? Just 2 problems. Just 2 problems. From section 2.7, problem B, problem 3B, actually. Problem 3B on page 113. So let me do this the way I've been doing it all along. which is page 113, 3B. This is a problem. There will be a question on the exam where I say f of x is equal to x to the fourth. No, it's not. It's not going to be this hard. It's not going to be this hard. All right. X to the fourth. The problem on the test will be x to the third. So that'll make it a little easier, actually. This is, you know, because it's x to the fourth, it's a little more difficult, but not really. So the first thing they like, I told you they love this question. I don't know if I don't know if this is on the test. I haven't looked at the test in a couple of days, but the first part of this is list all possible rational zeros. Now, this the possible rational zeros will be, remember, the factors of 6 divided by the factors, this isn't such a hard problem, of 1. So it's the factors of this term divided by the factors of the lead coefficient. It's the constant, the factors of the constant divided by the factors of the lead coefficient. And, well, you know, what is it? It's plus or minus 6 divided by plus or minus 1. You know, so you have to take into account the positive and the negative. Plus or minus 3 divided by plus or minus 1. Plus or minus 2 divided by plus or minus 1. Plus or minus 1 divided by plus or minus 1. In other words, these are all the possible rational zeros. That's not a hard problem. Use synthetic division to find the rational zeros. Now, normally, we are not told that there will be rational zeros. I told you that when it's to the third power, when the lead exponent is to the third power, we know there must be at least one rational zero. When it's to the fourth power, it could be all, you know, irrational numbers or imaginary numbers. But we know, but they're telling us. So they basically told us that there's going to be 2 factors of this, or 2 rational zeros. And we have to, you know, use synthetic division. They want us to use the fast method. So -1, 4, -6. Pick a number. Now, here are all the possibilities. Plus 6, -6, plus 3, -3, plus 2, -2, plus 1, -1. Pick a number. Now, I'm eliminating the 6. I just don't think it's going to be the 6.
-3.
Good. Try it. Well, you may have done this at home. It gave us the right exact one. Did you do this before? Because this comes.
For me,
What? 1, -3, -1, +3, 2, -6, -2, +6. You knew this, right? Okay, well, there it is. There's one possible rash. There's one. There's not possible. It's not a possible rational zero. It is a rational zero. Okay, so we've gotten that out of the way. Now we move on. So this is now x to the what? X to the third minus x to the second plus 2x minus 2. All righty, and this will give us 1, -1, +2, -2. And we don't have to, go back to the beginning to get the other ones. We just pick one of the other ones, so. Let's choose one. Now, if it's -3, chances are it's not gonna be -3 again. I'm just choosing, because you knew who gave me that answer? Who gave me that answer? Fama, yeah, you knew that, right? Okay. But let's choose one now that we don't know. Let's, -2. I wanna choose -2. 1, -2, -3, 6, 8, no good. I wanted to do one that didn't work. That's not good, because we want this to be 0. This has to be 0. Okay, so it's not gonna be -2 either. Okay, so let's move on to, 1, -1, +2, -2. Let's pick another number. Well, we picked -2, let's pick +2. 1, 2, 1, 2, 4, 8, no good. No good. 2 times 1 is 2. That's 1, 2, that's 4. 4 times 2 is 8, no good. But, we're eliminating, so it's gotta be either positive, well, it could be 3, but I don't think so. I think it's gonna be, let's try 1. Let's try 1 and see what we get. So bring down the 1, 1, 0, 0, 2, and 2. Yeah, that's gonna work. Yes. Right, so let me check that again, because I always work very fast through this problem, this type of problem. 1 times 1 is 1, 0, 0 times 1 is 0, 2, 2 times 1 is 2, the remainder is 0, therefore, 1 is another rational 0. So far we have -3 and 1. And now we're down to x squared plus, we don't have to put the 0x, right? I'm not putting it. And then +2 equals 0. Well, this can't be factored. So we know that the other 2 zeros are not going to be rational zeros. They're going to be, in fact, imaginary, because if we solve this, x squared equals -2. We take the square root of both sides, and x equals plus or minus I times the square root of 2. There they are. There's the 4 zeros. The 4 zeros are, I'm putting them over here. The 4 zeros will be x equals plus I times the square root of 2, negative I times the square root of 2, x equals -3, and x equals 1. These are the 4 values of x in this equation. See? It has 4 zeros. This tells us there are 4 altogether, and here they are. And that's what we found. We found one of them. I worked a little to get the other one, and then the other one turned out to be imaginary. I could see that coming. It doesn't matter. It could be imaginary. Here it is. It's problem on page 114. 114, problem 5. And you're given this function. F of x equals 3x to the third plus 14x squared minus 23x plus 6. list all the possible rational zeros. They love this question. Okay, but you know, you're gonna have to face this, certainly on the final. So once again, it'll be plus or minus 6 divided by plus or minus 3, but also plus or minus 6 divided by plus or minus 1, because the factors of 3 are either 3 or 1. So that's what makes this a little more challenging, is the fact that, you know, the factors of 6, the factors of 6 are 6, 3, 2, and 1. The factors of 3 are just 3 and 1. So you have to take into account that denominator. And now here, plus or minus 3 divided by plus or minus 3, plus or minus 3, plus or minus 1. There's some duplication here, but it doesn't matter. Just listen. Just go like this. This is how you do the question on the final. You will just do this. And plus or minus 1 divided by plus or minus 1. These are all the possible rational zeros. You do that, you get full credit for that part of the problem. The second part of the problem says, oh, excuse me. Use synthetic division to show that 1/3 is a zero of the given function. Wow, they're giving you, I knew this, you know, I'm trying to act excited because they're really giving you a very, very important piece of information. They're telling you that 1/3 is one of the possible, they're telling you that's it. Use synthetic division to show that 1/3 is a zero. That's really nice. So 3, 14, -23, and 6. This is a real, you know, pre-calculus question. So you bring down the 3, and it's a fraction, you know. They threw in they made this about as hard as you could make it. With all these things, and they're using 1/3 as one of the factors. Where would that be? That would be, oh, I didn't finish this, did I? Because this is also plus or minus 1 over plus or minus 3. And that's gonna be one of the, in fact, one of the zeros is, you know, positive 1/3. So 3 and 1, 3 and 1, 3 and 1, 3 and 1. Okay, good. 1/3 of 3 is 1. For those of you challenged with fractions, 1/3 of 3 is 1. 1/3 of 15 is 5. -18. 1/3 of -18, 1/3 times 18. Oh, but it's negative. Aha. There it is. Comes out to, it should come out to 0, and it does. Perfect. So that proves that 1/3 is indeed a zero of the original function. The original equation up here. Okay, that's what we just proved. This was the listing the rational zeros. This was proving something they told us would be anyway, so it did work out. Very nice of them. Now, what are we left with? 3x squared plus 15x minus 18 equals 0. Now, if you turn the page, they tell you find the rest of the zeros. The multiplicity of each zero and state whether oh, they want you to graph this thing. Oh, a really interesting question. Okay, we could do that. Now, what would you do? I'll tell you what I would do. Which would make this problem, I mean, if you wanted to find all the other values of x, you could use the quadratic formula. You could say, okay, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. You could do that. I'm not doing that because the numbers are going to be huge. B squared, that's 225, minus 4 times A times C, which is 4 times 3 times, I'm not doing that. I'll tell you what I'm going to do. I'm going to factor out a 3. I see that 3 goes into 3x squared, 3 goes into 15, 3 goes into negative 18. I'm factoring it. And what do we do with that 3? Get rid of it. Look what you're down to. You're down to a very, very easy trinomial factoring problem. And it can be factored into x plus negative 1 plus 6 equals 0. X equals 1, x equals negative 6. So the linear factorization. So first of all, let's not do it here. Let's do it over there. So first of all the zeros, will be 1/3. That's the one they gave us. X equals 1. That's the one we just found out. And negative 6. And the factors are x minus 1/3, x minus 1, the opposite of what we have. So this is positive, this is negative. This is positive, this is negative. This is negative, this is positive. There it is. These are the zeros. This is the, these are the zeros. And this is the linear factorization. The complete, that's what they call it, right? The complete linear factorization.